Hello मेरे प्यारे बच्चों, I am Mr. your Mohan sir, physics master from Hyderabad. Today we are discussing about the Kirchhoff second law. Before that, I welcome all the students from Kashmir to Kanyakumari. Good afternoon, good morning, good evening, and good night. Okay, Kirchhoff second law. Then let us discuss about the Kirchhoff second law. The algebraic sum of the changes in the potential. The algebraic sum of the changes in the potential across a closed loop is 0. So second law, that is called as the voltage law or loop law. It is called as voltage, Kirchhoff voltage law or loop law. So the algebraic sum of the changes in the potential. Changes means either increasing or decreasing, or the potential may rise or the potential may fall. The rise and fall of the potential, the changes in the potential, the decreasing and increasing of the potential, changes in the potential difference. Potential difference in a closed loop. In a closed loop or closed path or closed loop or closed path is 0. Should be 0. So the algebraic sum of the potential changes in the potential in a closed path should be 0. So a small equation you write it as delta V must be equal to 0. Delta V is equal to 0. Sum of the potential drops across the voltage source as well as the resistors. Across the voltage source or across the resistors, all this sum should be equal to 0. Now, if you take one source potential difference here, this is positive potential, negative potential. There is a positive potential and negative potential for a battery symbol. This is of higher potential. The positive one is at higher potential and the negative one is at lower potential. Current flows from positive to negative, whereas the electrons flows from negative to positive. So when you take from higher potential to negative potential, if the direction of the current is in the direction of the positive to negative or in the path direction you are taking, suppose you are taking in this direction, you are going in this direction, if you are going in this direction, then there is a fall of potential. Because there is a fall of potential, always keep remember the approaching sign. Consider the approaching sign, in which direction you are moving. The current direction I am showing from positive to negative, that is the approaching sign is positive. When you are considering the approaching sign is positive, take that the potential across this battery, E should be taken as, it should be taken. What is the sign here? Positive sign. You put one negative. It is negative. This negative. Negative sign. Take the negative one. Because the approaching sign, what that approaching sign you are getting, that one you just go with the opposite sign. That is negative one. You are just consider the negative one. So this is fall of potential. We are considering it as a fall of potential. Fall of potential. Fall of potential. So that is it E you are taking. Fall of potential. Now, in the case of resistors, you are considering one resistor here, current is coming in this direction, and if your path is in this direction, if you move in the direction of current, if you are moving, if you are considering in the direction of current, if you are moving in the direction of current, take the sign as negative IR, negative IR. Negative IR. I have my own trick. When my friend and I going in the same direction, when my friend and I am going in the same direction, yeah, he is a male, I am a male, then there is a repulsion between male to male, always repulsion. Okay, this is the trick I am following. Now when someone comes opposite to me, what happens? Yeah, it is a positive sign convention. Yeah, take the reverse, it is a positive sign convention. So like that we have to keep remember. There is the voltage drop. There is a voltage drop across the resistor. Yeah, V is equal to minus I into R. Yeah, like that by using these two techniques, you can go with the reverse sign. That means if you go with in this direction, it will become positive, a rise in the potential. If you go in this direction, to the against the direction of the path, against the direction of the path, we are considering the current in this direction and your path is in this direction. You are both are in the opposite direction. There is a positive sign you have to take. Understand? So like this we have to consider our what is that called as to keep remember for a long time. These sign conventions are very, very important for us. While solving the numericals, these sign conventions are very important. You always see that when you are traveling in this direction across the voltage source, so approaching sign you change. Positive one you make it into negative. When you are traveling in this direction, reverse current, if you are traveling in this direction, then approaching sign you change. Negative comes to positive. And in the case of resistor, the same thing happened. When the direction of the current and your path are in the same direction, then automatically you take negative. As if that your friend and both of you and your friend are walking in straight direction, so that your friend know it is negative. Okay, that is. So in this way we are going to consider that the algebraic sum of the changes in the potential difference in a closed path or a closed loop is always must be 0. Well, let me have one example over here. You have to take one example here. Here let me take one example. Here I will take one example. Now we take a positive sign and negative sign. Here one resistor is connected, and here one resistor is connected, and you take it. Here that the voltage V is here, and there is one resistance R1 and resistance R2. Now you start moving from positive to negative. Current is going in this direction from positive to negative. Now when you are going in the direction here, one you take from A, B, C, D. The path you have selected the path as A, B, C, D path. Now your current and the resistance, you are seeing the current and the resistance. Both are in the same direction. Both are in the same direction. So it is negative. So it is negative. So the current I and resistance minus I R1. Minus I R1. Why I have taken minus? Because the current and the path selected, the path what you have selected are in the same direction. So negative. Now when you come over here, BC, across this BC length, one more resistor is there, R2 resistor. And the current and the resistor, when you are seeing, when the path travelled by you and the current are in the same direction, take negative. So current and the second resistor minus IR2, minus IR2. You take minus IR2. Now come to the point B, come to the point C, along the point D, the path what you are travelling, and when you see here, there is a negative sign. Negative, approaching sign is negative. When you are observing the approaching sign is negative, you take reverse, positive you take. So there is a positive potential V, positive potential V here. It is equal to 0. Your statement is the algebraic sum of the changes, fall of potential, rise of potential. Changes means falling, increasing, decreasing. Your potential difference in a closed path, is equal to 0. Now when you take this R1 is equal to 2 ohms and R is equal to 3 ohms. Yeah, you are connected R1 value 2 ohms and R2 value 3 ohms. Now when you substitute over here in this formula, we have current, it can be calculated. We can calculate the current. So this is minus I, R1 is how much? 2 ohms. It is 2 ohms. Minus I, R2 is how much? 3 ohms. R2 is 3 ohms. Now take the voltage as 10 volts. You are making the 10 volts. 10 volts supply battery is connected. So minus 10. minus 10, no, here plus 10, you are taking plus 10 here. So plus 10 is equal to 0. Now here take minus I common. Minus I common means 2 plus 3 is. It is 2 plus 3. Taking the minus sign common. Plus 10 is equal to 0. Then minus I into 5 plus 10 is equal to 0. Then we want current, no? Then we want current. Take this current to other side. Minus sign changes to plus sign. The minus sign changes to plus sign when you take the current to this side. So here 10 is equal to, it is 5 into I. 10 is equal to 5 into I. Then I is equal to, what is I? I is equal to 10 by 5. 10 by 5. So it is 2 amperes. So the current in the circuit is 2 amperes. So by using this Kirchhoff voltage law, the changes in the potential difference across the closed path can be calculated. So we got the current. The current in the circuit. Now in this circuit we got the current. Current is calculated by knowing the direction of the path selected and the current direction. If you consider, we can calculate the current in the circuit. Okay children? Yeah, make a note of it. Yeah, there is many techniques are there to remember the subject. Okay? So here fall of potential, rise of potential. That is equal to change in the potential. So the change in the potential difference across the closed loop must be equated to 0. Then we call it as a Kirchhoff voltage law. Okay children? All of you make a note of it.